This is Zach Petro and Blake Pennington, and this is our Movie Recommender System project. Companies and people have been recommending products to customers in the form of advertisements for a long time now. For example, print advertisements in magazines or commercials on television. However, the dawn of artificial intelligence and machine learning has expanded the capability of product recommendation. With this new technology, everything from movies to books to restaurants and to products can be recommended better than a human could. With that being said, Blake and I decided to build a recommendation system and get a glimpse of how this technology works underneath the surface. We decided to build a movie recommendation system similar to what you see on your Netflix home screen, because it is a widely enjoyed form of media that almost everyone can enjoy. Because a movie recommendation system can take so many shapes and forms, we had to decide on the context of our system. Our system would ideally be used in the context of a movie ratings website, where users watch movies, rate them, and are then recommended new movies to watch based on the movies they have liked. It would be similar to websites like Rotten Tomatoes or IMDb, except it would include our system for the AI-based recommendations. The reason our system would need this kind of environment is our algorithm requires a useful amount of data to function correctly. This means it could not be a standalone service without a vast amount of user input. To get a simulation of this environment, we used the MovieLens dataset, which is a free and open source dataset that contains over 100,000 ratings of about 10,000 different movies. One of the first choices we had to make was whether to use collaborative or content-based filtering. The difference is simple, but had a large impact on how our algorithm would function. In collaborative filtering, the recommendation algorithm takes a large database of users' ratings of different movies and recommends to users with the same tastes movies that they have not seen yet but other similar users liked. In content-based filtering, the algorithm will take movies the user liked and recommend to them other movies which have similar characteristics. For our algorithm, we decided on collaborative-based filtering as it would recommend to users a wider variety of different movies instead of the recommendations being very similar to movies the user had already seen. As we can see here, there are several different types of recommendation system algorithms. We decided on a memory-based collaborative filtering algorithm as it fits our criteria, which is a wide variety of recommendations being chosen without the added complexity that a model-based algorithm would need. Specifically, we decided on the k-means clustering algorithm, which allows for a good trade-off of complexity and accuracy of recommendations.
For the scope of this project, and based on our research, we decided to use clustering. It fit our requirements that we wanted an unsupervised learning method, and that we wanted to group users by their similarities. We explored a variety of options for our clustering algorithm. We knew we wanted to use clustering because in theory, data points, which are the users in our case, that are in the same group, should have similar properties, which are, their ratings in movies. So we knew clustering would allow us to see which groups the users would fall into when we applied a clustering algorithm. So for the scope of this project, we decided to use k-means clustering. K-means works by first taking a certain number of groups and center points. Each data point is classified by determining the distance between that point and each group's center point, and then classifying which group that data point belongs to based on its distance to the center points. This process will repeat until the groupings don't change much. The end result will have groups of users that have similar interest in movies. K-means is also quite simple to implement and runs quite fast, as it won't have too many computations to perform. This allowed our recommender system to output results in a decently timely manner.
Our first task in building our recommendation system was to use k-means clustering to compare how users rate two different genres of movies. We chose to compare romance and horror movies because they are fairly different in their characteristics and the type of people that enjoy them. First, we pre-processed the dataset to only show the average ratings of users of romance movies and horror movies. Then, we filtered out the users that did not like either genre. Finally, we ran the k-means clustering algorithm with 3 clusters to get the desired result shown here. As seen in the scatter plot, the 3 clusters were the people that liked romance movies but not horror movies, as shown in purple, the people that liked horror movies but not romance movies, as shown in teal, and the people that liked both romance and horror movies generally, as shown in yellow. This exercise showed us that k-means can be used in a very basic way to gain insights into massive amounts of data.
After we better understood how to apply k-means based on our users' genre taste, we applied this process to how users rated individual movies. Using the Python library pandas, we merged, then pivoted users' ratings and movie titles to get a resulting dataset of users' ratings versus movies rated. Unfortunately, there were many null values as indicated by the white blocks, or here you can see them as nan values, because not all users rate every single movie, which is, understandable. We ran into a problem of k-means not accepting these non-existent values, so we had to convert this data into a sparse matrix. After we did this, it sort of shaved off a lot of these non-existent values, and then allowed k-means to operate in a correct manner. So after we fixed this sparse data problem, we then visualized an individual cluster as a heat map, as you can see here. Some interesting takeaways we got from this heat map was that it allowed us to spot patterns in the data. You can notice that some users will simply rate, on average, higher than other users, or that some users' frequency of rating movies is lower than others. You can also notice the general outlook of individual movies. For example, take a look at Forrest Gump. This column is generally very green, which indicates a high average rating for this movie. Overall, this allowed us to better understand our clusters moving forward. Since we were able to dive into each cluster, we could give and follow through with predicting how likely a given user in the cluster would enjoy a movie. Since the users in a cluster of users have similar taste, we took the average of the votes for that movie in the users cluster. This gives us a reasonable prediction for how well or likely the user will enjoy the given movie based on a scale of 0 to 5. Being, of course, the closer you are to 5, the more likely you are to enjoy that movie. As you can see in this example use case, we can see how likely a given user would enjoy the films Forrest Gump and The Lion King. Being Forrest Gump, you would be predicted to have a rating of 4.2 and Lion King of 3.95. So we applied similarly what we did in the previous slide in recommending a movie or a list of movies to a user. So given a user, we output a list of recommended movies based on what they have not watched before, what they have watched, and how other users in the cluster rated the movies our user has not watched. This recommended list is in order of highest ratings first, or descending order. So for example, let's suppose Bob is user ID 4 in our cluster. With this, we gather his ratings for movies he has watched and the ratings for movies he did not watch based on other users' ratings, then sort accordingly. In the end, we have a recommended movie list for Bob. Bob is now happy.
To conclude, our recommender system uses a collaborative filtering-based algorithm to determine movie recommendations. The algorithm used is the k-means clustering algorithm. For our algorithm to work properly, we need vast amounts of user rating data, which was contained in the Movie Lens dataset. We had some takeaways from the project as well. First, we should continue to explore other clustering algorithms such as GMM, or even explore other recommendation systems other than collaborative filtering. These other systems may boost the accuracy or likability of our predictions. Second, We can improve the accuracy of our system with a hybrid model or more pre-processing methods. While a hybrid model is considered state-of-the-art as it is used by Netflix, the computing processing power required is much more than a non-hybrid system. We hope to continue exploring new methods and algorithms for movie recommendation into the future.
If you have any questions or suggestions, feel free to contact me or Zach at jbpennington1 or Petro at crimson.ua.edu. Both of us really appreciate you listening to our presentation. Thank you so much for your time. This concludes our presentation.